Now we are going to the selection operator, some examples. The list all staff with the salary greater than 10,000, isn't it? This is normal your DBMS queries language. You using the SQL query, select star from the table name, the where statement, you just apply something, okay? But the relational algebra, it's a reduce some parenthesis, that is called, you just using the symbols, okay? Likewise, what the predicate assessment, then that is called the predicate is this condition statement, the salary greater than and 10,000, isn't it? We have to knowing that the salary table, it is the columns, okay? Then staff is the table. Now you related this example with an syntax. So pi symbol is there and the predicate is there and the R is the relational. So I wanted the example is output. Those who are the maximum salary above the 10,000 is, there are 4 lists. One is the John and David and Susan. Okay. So next one with the projection. So what is mean by a projection? It's a sense the work as a single relation is R and define a relation that constraints of the vertical subsets of R. You know that vertical itself, I just column wise I segregated. The symbol is pi symbol. Then it is the predicate, that is column 1, column 2, column 3, etc. How many you want the columns as retriever, you just column in. And R is the relation. Now the example is predict a list of the salary for all staff showing only the staff name or staff number and the first name, then salary, isn't it? So now how do you apply that? So we just see the previous example. I just the same thing. I just so find my symbol also and predicates what is the statements you want. Just is a staff name, then staff name, student, first name, then last name, again salary. With the table is staff at a table. So you just executed the 4 columns itself, I just retrieved. Okay, so this is the predicate of some example is. The next one, union. So union is the merged from 2 different tables. Okay, so maybe and repeated elements are there, are presented as anything else, you just combined with the 2 different table just twice. So R is the one table, S is the another table. So R and S just union, that's all. So unions of 2 relation R and S, it's a define a relation that contains of all tuples of R1 and S. Or you are both the neglected, okay, or you just simply for the normalized or dispracticed. Then the tuples being the eliminated, somewhat occurred with some duplicators, totally that's mean I think automatically they have to eliminate it. That is called normalization functionality. Then R and S must be the union complement. Then some example is, and then next slide, the union of example. So list all cities where they either is branches, office or property for rent. Here 2 different tables are there. The first one is the branch office, another one is the property for rent. Now how I just merging for, I combined with the common session of the 2 different table itself, I am using the predicate function, okay, that is called projection, because I just wanted the vertical assignment, okay, well, so that the pi symbol and the city is the branch office table and the branch union of again symbol, then city of property rent. Now 2 different table, its common name is city and city. So wise we have to combine the 2 different table, which element to be common precise as the displays, that's all. The next one set difference, already you know that the definition is R minus S. This is the concept of set difference that defines a relation consists of your tuples that are the relation R but not in S. So that's the meaning. It's a presented of R table something. Okay, for example, London, abroad, Galaxis, Brussels. But yes, it's not the mandatory precise. Okay, so that is the concept. Some examples related. List all cities where there is a branch office but not property for rent. Which means you have to presented your, which means branch office but not presented of your property rent. Okay, how do you identify the predicate symbols, the city, and here also property rent is the city. Now the common set of symbol is minus. So both the table is totally different but common table is precise. So now I have to Bristol is my output. Then move on the next one. Intersection, as it is same relevant. So R intersection of S, this is symbol, The definition is a relation consists of a set of values that is the tuples of R but not be mandatory assessment. Okay, it is automatically rebooted of constraints to which constraint you satisfied or what are the predicted elements do you want, it automatically eliminated or you have to add it. So for expressing using the basic operation itself, R intersection of S equal to R minus R of minus, so that the two table with the inner table again we move on the solution of another table. So list some example, list all cities where the both branches office and at least one property for rent, which means so intersection, it's first of all the R and here of S, okay, R and S the intersection value. So now the city and city, so both are the common set. The previous itself the set difference, okay, so which means this table should not presented at the Bristol itself display, but here the city branches also presented as Aberdeen, London and Glasgow. There is three value or three item also presented of your property for rent, that's all. Okay, then Cartesian product add as R and S though intersection. So define the relations that the constraints of every tuples, the relation R will be the relation of S. So some example, list the name and the columns of all cities who have viewed the property for rent. So that the examples are so Cartesian product example. So here, so I just seeing that. So pi symbol, client number and the first name and last name. As it is, this is table as client table, and weaving table we have to client number, then property for now and comment. Okay, both the table have common set as client number. Okay, client have a client number and weaving have a client number. So this is the constraint. Okay, this constraint will satisfied of infinity finites, so I have to some related of some output. Okay, then after that some example of Cartesian and the selection process, there use the selection operation extra tuples with the client dot client number equal to viewing dot client number. Already you know that the viewing have a client number and client have a client number. How to contradict? Okay, so contradict itself. So pi symbol, this is the selection process, because of I want from hold the tables. Okay, what are the presented of table as in element. So client dot client number equal to weaving dot client number, both the table is equal. After then the client number, what are the constraint you want. Okay, for example client number, first name, again last name for client, then as it is weaving table constraint of command, then client number and property for rent. So example is that's all. Then move on the next one, join operations. So join operation is a valid property of the RDBMS, okay, which means we have to compare with the two different tables and analyzing from some pathological situations occurred in your tables or database or data administration itself. We have to easily modify and easily finding the how to you retrieve some solutions. Okay, the join operations is related derivative of Cartesian product. Okay, so that equal performance the selection and using the join predicate and what are the selection properties occurs in your relational algebra, the everything is comes again your joining operator also, joining process. Once the most difficult operation to implement effectively in RDBMS, and one of the reason why RDBMS is have the instruction performance problem, because that is already I told you. So totally two different tables we have to merging something because table 1 have 5 columns, table 2 have 6 columns. How to merge this? This is some troubles. Okay, that the situation we have to easily identify, then easily modify some resolution is this type of variations. Okay, that is called theta object, then equity, natural join, then outer join and also semi join. So first of all theta join with the symbol as it is follows, then our neglected of S and S, that is called functional property. The definitions of relation that constraint tuples satisfy the predicate of F, that Cartesian product is R and S, that is called relational, that's all. Okay, maybe a table A is the 5 element, table B is a 6 element, maybe this is the equal or greater than or less than, that's all. So simply called as the Cartesian product is over. The next one, theta project is completed. Then move on the next slide. So some equity join is the list all the names comment of the all client who have the viewed a property rent. This is the more important. So I want the comment itself all clients who have a viewed a property rent. That's mean two different table you have. View table, it's a table, sorry, client table is there, and another table is view. The both the table is which columns are commonly presented of both table, that the table is only for the merging. Okay, so some equations I followed, that is called some parenthesis. I think some queries are presented, so equally follow some output level. The next one, natural join. So natural join is R some space of S. So an equity is two relation R and S, overall they all comment of X. Then once occurred of each common attributes eliminated from the result, that is called natural join. Is the overall the every process is naturally joined. Okay, naturally we have to some join at the two different table at the time is some what is that? I think some constraint will move on. That constraint we have to satisfy some methodology. That is I given some examples. List all the names and the comment of all client who have viewed of property rent. So both are the same but slightly different. Okay, so here I pi symbol, but here I am using the two different. Okay, so client comma file, first name, last name, and the client. Then as it is comment, then client number, then comment. Okay, both the table client and viewing, two tables as common name, that is called client number. Okay, so that easily I have to joining, that's all. So over the natural join. Then next one. So that's the process. The given is some output. Then outer join is to display as the result the outbound of the characteristics. Okay, outbound of your table, which my table is totally completed. The extremely joined with the another constraint to satisfy. Yes, it is possible to move on the outer join. So I given us example proceeded a status report to the property for viewing. I just want some report. What are the report as represented your property rents? Just property number, comma street and cities. Three constraint I will satisfy. Then it is totally viewing constraint with the invoking method will apply. Okay, so invoking method is in a sense already told that is purely based on the mathematical terms. Okay, then I gave some examples. Move on the next one, semi-join. It is the same process to your theta function. Okay, as it is same reversing process also. Then f functions are subtracted to the pi symbol of A, then R subtracted of S. That's the example is list the complete details of all staff who have worked with the branch in Glasgow. So just to say that's all, staff dot branch name. So staff dot branch name equal to branch dot branch name. Here two different table. One is the R and the S. So R is the staff, S is the branch, that's all. So totally combined with the which constraint you want, the gloves you want. So that equal to gloves. So output is some predicate, that's all. So even the division is as it is mathematical same function is R division of S. The defined relations over the contributes of C consists of tuples and all the that much combination of very tuples of S. So expression is called T1. T1 is the table, then pi symbol is then R. So which constraint is R intersection of table 1 as it is Cartesian products invoking the method of R, then as it is 2 is Q table is combined totally with the neglected of some constraint. So overall this satisfied of your division processing. So move on the next one. So examples related. So here viewing and also property rent, two different table. So first table we have to who have viewed all the property with the 3 rooms. Okay. So I just give the client number, property name number, which means why the property number and the client number, because of the client number is common property for both the table. Okay. So property table have a property number. So I just some constraint will be pi symbol as room equal to 3. Okay, I am my constraint. So that I room equal to 3. So satisfied, first viewing is some properties and analyzing for the Cartesian some property number. Then finally result is both the table is repeated which element 56. Okay, because of 56, 36, then 56 again PG4, again 56 and PV4. So totally the C56 is the repeated from 3 rooms. So that my result is CR56. So that's all about today's session. Okay, so after that we move on the next classes. Okay, thank you.